So it's back, long division. It's not going anywhere. You're going to use it all year, so you're going to have to get used to it. However, now you have your choice. You can do long division by an algorithm, or you can do long division by reverse tabular. So we know that if we have this particular problem, x squared minus 9 over x plus 3, we know that we can factor it into x minus 3, x plus 3. Below, we have x plus 3, and we cancel out, leaving us with the remainder, the quotient x minus 3. But what happens when it's not a perfect division? In other words, we have a remainder. Something doesn't go into something equally. So we have down here x plus 4, and then I've written x squared minus 9. Remember, you have to go in decreasing order with your degrees. So this goes squared. The first degree is not present, so it must have a zero coefficient, minus 9. X times x gets me this x squared. X squared plus 4x. Draw your line, and remember now we add the opposite. So we're adding, we take the opposite, which means we're really subtracting, and we start our algorithm all over again. How many times does x go into negative 4x? Or in other words, negative 4 times x gets me negative 4x. Negative 4 times 4 gets me negative 16. We're going to subtract by adding the opposite. And there you have it. You do not have a remainder of 0 like you did in Unit 1. Instead, you have a remainder of 7. Now, we don't write remainder 7. We're doing big boy and girl math. So remember how when you divided something, let's say you did 5 over 3, and then you would say 3 goes into 5 once, 2, and you would write it 1 2/3. Well, we're doing the same thing right here. We're taking that 7, and we're putting it over the divisor, which was x plus 4. And since this was a positive 7, a positive sign goes right there. There, you just did long division, but you had a remainder, and you didn't get a 0 down here. If you were doing it reverse tabular, no difference. Remember, we put the x squared in there, and we say, okay, x times x is how I got x squared. Continue your column. This is 4x. This must be minus 4x because there was no first degree. There were 0 x's. So that's minus 4, minus 16. And here's the problem. Well, here the 7 came right out. This doesn't mean I have a remainder of minus 16, because normally on a reverse tabular we had to end. We still need to get this negative 9 to show up. How do we get that negative 9 to show up? Well, this must have been 7, because 7 and minus 16 gets me that negative 9. So since there was nothing multiplying left here, this is your remainder. So you had x minus 4 plus 7 over x, plus x plus 4. No, it was a minus. Okay, so remember, Common Core is all about looking at polynomials and breaking them down so we can study their maximas, their minimums, their roots. And long division is a very powerful tool when we get to those polynomials that, well, they just aren't pretty. So this is what Common Core has been developing you to do. Let me jump to a blank page. We tortured you with factoring in 8th grade. Now we're moving on to division, and there's two types of way you can divide. You can do long division or you can do the tabular. But all of these help you find the roots of a polynomial. So factoring is the easiest way to divide polynomials. So when you're looking to do these problems, sometimes they're very factorable. Just don't see division and automatically go to long division or a table. Take a quick look, maybe they do factor. If not, then you have to divide. So in example 2 here, it tells you, find the quotient by factoring. So I can look at this and say, oh, this is a trinomial, and it factors very quickly. So there, that's the quotient. When you divide this trinomial by this binomial, you have that as an answer. Now, if you can't factor, you can always divide out. Find the quotient. There, they're just asking me to divide. So it didn't tell me I had to factor. It didn't tell me I had to do long division. It didn't tell me I had to do tabular. But I'm going to take a quick peek at this because it's short and see, can I factor? Let's see, are there any numbers that multiply to 5 that add up to 3? No. So I guess I have to do long division. Now I have to be aware that sometimes my long division will have a remainder. Sometimes it won't. So I don't care which method you use. I don't care if you like the long division. I don't care if you like tabular. Most of you have said you like tabular, so let's just stay with that. Okay, x squared. That first number goes in there. So that's going to be x. X times x is x squared. This is 2x. All right, I have 3x. So that means this has to be an x. 2x plus x gets me that 3x I'm looking for. So this has to be 1, because 1 times x is x. This is 2, but that is not my last number. My last number is a 5. So what has to be in this spare box to get me 5? 3. But since there's nothing left to multiply, that's a remainder. So the quotient of that is x plus 1 with a remainder of 3. And if you had done this down here, remember that would be x. So that's x squared plus 2x. Draw a line. Now we're going to subtract. So anytime we subtract, we add the opposite. And that gets me x plus 5. That goes in there once. X plus 2. I'm going to add the opposite to subtract. And look, there's my remainder of 3. Plus 3 over x plus 2. Example 3, read carefully. Find the quotient by factoring. It factors, and this is the last type of factoring we are trying to scrunch into your brain. This is a difference of perfect cubes. So they want you to be able to do a difference of perfect cubes as quickly as any other factoring. So we start by taking the cube root of the first term, the cube root of the last term, and this gets a minus put in the middle because it's a minus. Then the remainder trinomial is, well, this must be x squared, because that's the only way x times x squared is going to get me x cubed. That means 2 has to be squared to positive 4. And then I simply multiply these two values together, 2x, and it's plus, because I'm only allowed one subtraction sign when I'm factoring a difference of two perfect cubes. Now the x minus 2's cancel out, so this must have been x squared plus 2x plus 4. Great, this factored, so there was no remainder. However, the next one, I think you got the trick now, there's going to be a remainder. Find the quotient means divide. X cubed This must have been x squared. Minus 2x squared. Okay, now look, I don't have any x squareds, and I don't have any x's. They all have to equal 0. So that means this has to be 2x squared, because they'll cancel each other out. So that's got to be 2x. 2x times x, 2x squared. This is negative 4x. Okay, I don't have any zeros, so this has to be a positive 4x. So that's going to be 4. That's negative 8. Well, I'm left with negative 4, so that means I must have a remainder. What must be left over to add up to negative 4? Well, this has to be a positive 4. So when I divided this out, my answer was x squared plus 2x plus 4 plus 4 over x minus 2. That was my remainder. And just remember, if you're going to use the long division for this, you would have to write it as x cubed plus 0x squared plus 0x minus 4. You have to write the whole thing out so you don't miss any division steps. Now, yeah, later on, maybe when you become a little more adept at math, you can skip those middle steps, but not right now. And it doesn't matter which way you do, you will get the same answer either way.